All right, this is going to be verifying trigonometric identities 5-2 in trigonometry. And I know we don't have any problems with people playing with their phones right now because I might throw something at them because I'm having that type of day. All right, so for this right here, you need to have your stuff with you. You need to have your unit circle. You need to have, you know, just about all your material. So all this right here is important things. They're good things. You could read. Okay, so I'll read through this for you. It goes wah 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 wah. Still, keep more. Oh, dang it, there we go. Okay, still not enough. All right. All right. So now that we finally got down to the good stuff right here. Okay, now that we finally got down to the good stuff, let's go ahead and take a look at what we got here. So we are working with one side. Verify an identity by working with one side. If you learned anything from the last unit, then you should be fine. Okay?
What was the last one?
The one you did yesterday. Okay, so we're going to make each side match. To verify an identity, we're going to make the left side match the right side. Sometimes a little bit confusing, sometimes gives you a pain in the butt, but they always work out. Okay? And it doesn't always have to be the same side. It could be either side, the one that looks easier. By looking at that, I have cotangent plus 1 is equal to cosecant times quantity of cosine plus sine. Okay? Let's translate this first. Translate it. So what are we going to have translated? Translate this in algebra. What do we get here? X over y plus 1 over y quantity.
X over 1 plus y over 1.
Very good. Which one do you think is going to be easier to do the work on?
The right side.
The right side. So we're going to make the right side look like the left. The reason why, because after I distribute, it might actually come out pretty good here. Right?
Yeah.
So otherwise, I would have to do some weird stuff over here, and I'm not ready for that. Rah. Okay? So let's go ahead. We're going to work the right side of this. It doesn't matter which side. We could make this one into that. It's just going to take more work. Look at it. Which one do you think is going to be easier? Okay? So let's go ahead and do the distribution here. On the right-hand side. So it's going to give me x over y plus 1. Oh, snap. Hey, look. Right after I distribute that, doesn't it come out to be the same?
Yes.
So this and this are now the same. So I was able to verify those identities. Right? Okay, so now what does this turn into? Let's translate it back. There you go. Cotangent of theta plus 1, right? So it works out very easily. Okay, so what part? Okay, start somewhere.
So do you just ignore the whole, like they equal each other?
No, you're not ignoring it. You're making one side look like the other. We're verifying an identity working one side. So you look at both sides, you're like, hey, I don't think I want to do that one. Let's do this one. So after my distribution here, does my left side look like the right side? Yeah, that's it. I just verified the identity.
That's all you're doing?
Yes.
But then, what's your answer? Just cotangent?
Are they equal?
Yeah.
Okay, so does my work show that they're equal?
Yeah.
It's not the answer I'm looking for. I'm telling you they are equal. You know they're equal in the first place.
But it's proving it.
Proving it. I want to see the work to go from here to here. That's what I'm saying. Okay, it is kind of complicated in the sense that you have to look at, see what you got, pick out which one you want to work with, and then go from there. Okay, let's try another one. Another one's going to be a little bit more complicated. Actually, a lot more complicated.
We've already started.
Oh, never mind.
Hey, trust me, you got this. You got this. Okay, looking at this, just looking at it right now, which side do you think we're going to work with? Okay, we're going to work with the left. So let's go ahead and start off by translating it. Translate it. What do we have over here? Y squared over x squared, right? Quantity. 1 plus.
X squared over y squared.
Very good. Okay. Equals 1 over 1 minus y squared. Now, I'm going to tell you, I'm going to cheat a little bit on this one. Okay?
Are we allowed to?
Yeah.
Okay.
Because I think it's the next example that comes up that you're going to work both sides to make them work. So, because the right side's kind of messy, but you're going to see where it's going to work out. But we're going to make the right side into the left side also. So we're going to work the left to a certain point. We're going to get a nice, pretty answer over here. And then we're going to try to clean this up a little bit, and we're going to get the same pretty answer as the way we had on the left. Okay? So even though it says one side, but this trick to do as much as we can over here, then make this other one look like it. Okay? We could work both like this. Okay, first thing I have to do is what? Distribute. Let's do that. So as I distribute, I get y squared over x squared plus, what's going to happen here? 1, right? My x squareds canceled, my y squareds cancel. 1. Shh. Some people, hey, someone need to make sure their phone stays off. That's not Snoopy, it's Peanuts, get it right. Okay, equals this. All right, so now I have this one right here, so I'm going to do a little bit of finagling here. Finagling.
What does that mean?
I'm going to do some moving because, you know, like Madagascar, we like to move it, move it.
All right, that's a little more work.
Okay. I know, I tried. Okay, so I'm going to take my Pythagorean identity. X squared plus y squared equals 1. Okay? That's the Pythagorean identity. Okay, this is my Pythagorean identity. So I'm inserting my Pythagorean identity here. Now, can I make my Pythagorean identity look like this?
Yes.
What would I do to my Pythagorean identity? Divide everything by x squared. Very good. Everything by x squared. So, what's going to happen here? I'm going to get 1, right? 1 plus y squared over x squared equals 1 over x squared. Right?
So 1 over x squared becomes our new thing that we start to use.
Okay, so I was able to.
So what happens to the y squared?
I haven't done it yet. So I haven't changed it yet. I'm going to change it right now. So now we know so right here, is it still red? Didn't you? Okay, so I got this right here, didn't I? I got this, and then I use my Pythagorean identity here. What can I replace this whole thing that I just circled with?
1 over x squared.
1 over x squared, because isn't that the same as what I had right here? That's the same, right? There's a plus sign in between, so yes. So this is the same as this. So now, I could just say I have 1 over x squared. And I'm going to stop right there. Okay? Like I said, I'm going to fudge you a little on this one because this is pretty. I like this one. This works out very good. It's a very simple answer. Now, I'm going to come over here to this side. Okay? I'm going to come over here to this side. And I'm going to go with a couple things. I know using my Pythagorean identity that x squared is equal to, what would I do if I move x?
1 minus
1 minus
1 minus y squared. Very good. What about y squared?
y squared equals 1 minus x.
Very good. These are going to be used all the time. I need you to add those to your notes. Okay? These are part of your identities that you're going to use so much that you need to actually have it somewhere. Okay? So, I took my Pythagorean identity, I moved it around, I came up with these right here. Just by subtracting, for this first one, subtracting y squared from both sides, and the other one is subtracting x squared from both sides, right? Okay, so now, right over here, for this one right here, so the 1 over 1 minus y squared, can I replace part of that?
Yeah.
What can I replace?
1 minus y squared.
I could replace 1 minus y squared with what?
X squared.
Okay, so that's going to be equal to 1 over x squared, isn't it? So we were able to move and work both sides of the problem. We worked the left side down to this right here. And then just by a little bit of fudgy over here, just by looking at the identity, be like, oh hey, this one is 1 over x squared, isn't it? So I could actually come out and I get the exact same thing on the left side and the right side. I know I got some blank faces staring at me right now saying, what? And you know, I think Brady's still asleep because he looks like he's trying like falling over right there. You alright?
So it's cosecant squared?
Yes. This one is going to be secant. Okay? So this one on the left boils down to secant squared, is it thetas? X. And the right hand side also comes out to be secant squared x. So both sides come out to be the exact same thing. So it's good at the very beginning knowing that they're going to be equal. We just have to find the way. And don't even say it. Don't even say it.
The way. The way.
You know I'm recording this, right?
No, we're not.
If you really play it, I swear I'm going to hit you in the face with this onion.
Wait.
Anyway. Okay. Anyway, all right. Questions, concerns, complaints. Corin, are you going to be able to do this on the test that's going to be on Tuesday?
What? Daniel, Mr.
Yeah.
Does it get harder than this? Or
Okay, remember what I said?
No, but-
I'm going to try and give you the hardest problems on the notes. When you do the homework, they're not as hard.
It was such a lot. I had a lot of trouble on 61.
Actually, 61 was easy.
No, it was not.
You're like a
Bet.
you're a
I
mathematician.
remember what it was. You remember?
All right, so, okay, for right here, this is where I'm going to leave off with the notes. So don't forget to like and subscribe.
Are you recording? Oh, he was.